Hello.
How are you?
Good. How are you?
Good. Thank you.
Sorry, I got a little caught up yesterday and I was reviewing like the things that you sent me and I got stuck, so I didn't go over the rest of the
Sure.
check question. All right, let me share my screen. Is it this one or did we finished? Did we finish with this one?
Oh
I
yeah.
don't
So
I looked off on it.
yeah, so voltaic cells and electrolytic cells. So a voltaic cell, um here, let me do this.
Is it like based on voltage charge? We said that it was like going from anion to cation.
So here, open this link up. It's in the shared drive.
Mm-hmm.
Oh yeah. So it'll be called electrochemistry.
One or just this one?
Okay. So a voltaic cell is the same thing as a galvanic cell, which is the same thing as a electrochemical cell. And
Mm-hmm.
what you do is we take advantage of the natural difference in reduction potentials of two different metals to
Mm-hmm.
spontaneously generate an electric current. So you'll have the cell potential always be positive. The cathode is positive, and the anode is negative.
Okay.
And whichever like species has the lower reduction potential, that will be the thing that gets oxidized and gives its electrons to something that has the high reduction potential. And so I wrote that here.
This is the same thing that we were talking about in the other one, right? And like I think it was even the last two that was saying that like because remember the first one it was asking like if something's more electronegative, what has the highest like reduction potential? And so since it's electronegative, it gets oxidized, right?
Uh so yeah, I don't remember that question, but I know that we saw the one about the voltaic cells, and
Uh-huh.
that's its own like big thing. So that's what this is for.
Okay.
Yeah, so basically the thing with the lower electric potential will give its electrons to the thing with the higher reduction potential. So I wrote higher the reduction potential, the more likely to be reduced, aka gain electrons. And so we have an example here of an electrochemical cell, and we can see on the left that we have a strip of zinc. You've seen this before, right?
Yeah.
Yeah.
With the salt bridge, right?
So basically, yeah, if we're comparing a strip of zinc and a strip of copper, like I wrote, so you'll often be given half reactions, which will be like a reduction half reaction usually. And so we have two reduction half reactions here, like one for zinc, one for copper.
Mm-hmm.
And the one for zinc is negative 0.76, and the one for copper is positive 0.34. So whichever one has the higher reduction potential will be the thing that gets reduced.
I feel like my Zoom keeps getting stuck.
Oh,
Like it's breaking up a lot.
hmm.
Maybe this.
Oh, are you using right now this?
What?
Oh, are you
I'm just switching Wi-Fi's because I feel like it's breaking up a lot. Why did it leave the?
Yep. So you can see here compared to like copper that zinc has the lower reduction potential,
Uh-huh.
right? And so that means that it's going to be the one that gets reduced,
Yeah.
which means that the zinc will have to be oxidized. And so that means that we're going to draw the half reaction in the opposite direction. And we're going to take the reduction potential and we're going to flip the sign.
Mm-hmm.
And then the cell potential, the one for the entire cell, is the sum of the reduction potentials and the oxidation potentials. And so the cell potential here is going to be 0.34, which is the reduction potential of copper, plus positive 0.76, which is the oxidation potential of zinc, and that gives you 1.1. And there's a formula, delta G is equal to negative NF
E
cell.
cell. Yeah.
Yep. So you could see that if you have a positive cell potential, the overall number would be negative, right? Because of this negative sign.
Does E cell stand for cell potential? Okay.
And so, yeah, that negative in front um, makes it so that if you have a cell potential that's positive, the delta G would be negative.
Okay.
And that's why positive cell, so that's why, so for galvanic cells, or, same thing as electrochemical, same thing as um, voltaic. Uh, we have a positive cell potential, which means a negative delta G, which means spontaneous.
Okay.
So, okay, now that's in the voltaic cell. Now I wrote here, eventually all of the electrons will reach the cathode and all of the cations will reach the anode. This is equilibrium, in other words, a dead battery. So this is like, by the way, like galvanic cell, voltaic cell, like these can also be called concentration cells. Like, for instance, like the one in your phone and on your computer, lithium ion, like has a high amount here, a low amount here. So if you connect those with a wire, you'll have electrons go, you know, from
To the
here.
positive side.
Yep. And it'll go until
It reaches equilibrium.
exactly. And then you'd have the zero charge there. So what you can do then is like,
Introduce like an additional like negative charge, right?
yeah, yeah. So you can plug it into an outside like electrical source, like an outlet or a battery, and it will force the entire uh reaction to happen backwards. So you can go
So it
down.
brings in protons, not electrons.
Oh, so it'll bring in electrons, but force it to go in the opposite direction.
But how? Why would they want to go towards the like the negative? Oh, because it's zero now, so it doesn't matter.
Yeah. So once you plug it in, so you'll see if you scroll down. So, oh, I guess I didn't really draw it out. But yeah, you want it to go backwards. So like if we were to have that battery example, like imagine this you plug into the outlet, it's going to flip the signs of the like anode and cathode. So you're going to get a positive charge here and a negative charge here. And that's just because we're forcing it to go backwards, which means we want this time electrons to go to this bottom part that's positively charged
Mhm.
instead of the top part that's negatively charged. And this happens until, you achieve that concentration or chemical gradient again, like that separation of charge. And once that's done and it's finished charging, you can unplug it and then it'll go back to this bottom part being negative and this top part being positive, and it's just being a regular, voltaic cell.
Got it.
Yeah. And so these are just some examples of it, like electroplating, recharging a battery, and electrolysis. But for the most part, yeah, that's it. So, so yeah, remember basically that in an electrolytic cell, it's going to be the opposite. So instead of it being electrons going from a low reduction potential to a high, it'll be electrons from a high reduction potential to a low. And cathode is negative, anode is positive, and the
Mhm.
cell potential is negative, which means that it's not spontaneous. So it's a galvanic cell in reverse.
So the delta G is positive, right? Okay. That's what I wrote. Right? Because positive cell potential would be a positive delta G, non-spontaneous. Voltaic is spontaneous, so C is wrong. They would have high energy because of the positive. So D is wrong. A is spontaneous, but it doesn't really say anything about the external device, right? So B is the best.
So I guess they're using some weird wording here to mean when they say high energy, low energy, like, yeah, this is just not worded properly, but I think what they mean is high reduction potential.
Hmm.
So think of it that way and see if that.
Oh. So would an electrolytic have a low reduction potential?
Um,
Or no, they have
oh,
the other one, the voltaic has low reduction potential because it has high oxidation.
yeah. So this question's not the best because of the high energy part, but yeah, you're thinking the right thing, but it's just going to be A just because it says spontaneous, but you're thinking in the right way. This is just the question is not using like the proper words for the high energy part.
Right.
Yep. Oh yeah, so now
I just thought that this would be the most negative,
yep.
so I thought it would be
Yep.
this.
So now yeah. So now that you have, the knowledge and stuff, what should this be?
the strongest reducing agent, which means it gets oxidized. So the overall delta G would be negative. So I think B is correct.
Yep. So yeah, if it gets oxidized, like it'll have the lowest reduction potential. Good.
Um,
Mhm.
I couldn't remember if two was true.
Uh-huh. Yep.
I assume that one wasn't because it feels like double bonds would be harder to break than a single bond. So I don't think that it would be the strongest.
Yep.
And then it makes sense to me that like
Mm-hmm.
that three would be true. So I was kind of just and th only three wasn't an option, so I said two and three.
Yep. Yeah. So single bond will just be a sigma. Double bond, one
Is
sigma
it bad?
pi.
Yeah.
Triple bond, one sigma, two pi.
Okay. All right.
Mhm.
I like can't visualize it from two pentagons,
But
which one it is.
yeah, no, you're right on this. So,
Okay.
is there's no these are non-polar molecules, so there's no dipole and there's no FON, FON, so there's no hydrogen bonding. So, yep, good job.
I remember, I think it was in Orgo, my professor said H on the phone.
H on the phone.
Like
Oh
there's
yeah,
no hydrogen bonding, like
got
FON.
it. Yep, yep.
Is this right? I can't.
Uh, well, this one's I think they made a mistake on this question. Um, so yeah, I would say it's a good choice, but not the most important.
Because when I was looking at it, I was like four, because N wants to form four bonds
Okay.
and have zero valence electrons.
Mm-hmm.
And then oxygen wants to have two and two. So just with what I know, this felt like the best one.
Mm-hmm.
But what do you mean by it's wrong? Because
Oh, like when they wrote this, I think when you actually there's more than one like answer that will give you the right amount. Like the answer that they will have is A, but so basically, let's see.
why would that be resonance stabilized?
Um, so yeah, I guess so in general you want the charges on the atoms to be as close to zero as possible. And so for the nitrogen atom, like this one, you have one, two, three, four, five. So like, five bonds and nitrogen has five valence electrons. So there's no more, the charge on this is zero. And then for the second nitrogen, we have one, two, three, four um bonds. And if we have five valence electrons, we have, one uh left over. Um, so it would have to lose one to make the four bonds. So this would be plus one.
Mhm.
Here for the oxygen, it's one, two, three, four, five, six. And seven for the bond. So it gains an electron. So that'll be negative one. And if we do the same thing for B, we have one, two, three, four, five, six. So if we have 6 bonds from 5 valence electrons, it means we need an additional electron. So it becomes -1. Then the nitrogen in the middle has 1, 2, 3, 4 bonds.
Can
So
you show me what you're counting? Because,
yep. So
like, for example, here, 1, 2, 3, 4, no? Are you counting each, like, pair of electrons as one? Like, 1, 2 electrons?
just the number of valence electrons minus the number of bonds.
But
So
here, there's 4 valence electrons and 2 bonds, right?
mhm. Yep. So
So
uh
it's 2, not 1.
so nitrogen has 5 valence electrons minus these, like, well, 1, 2, 3, 4, which is what we have. So like this is really bonds plus, lone pairs or lone electrons.
Mm-hmm.
So yeah, so for the nitrogen here, we have, well, nitrogen will always have 5 valence electrons, but we would subtract it by the number of bonds, which is 2, plus the number of valence electrons that they've drawn, which are 4. So this would be 5 minus 6 to give you negative.
-1. Okay.
Yeah. Um, so yeah.
Okay.
Yep. And then yeah, formal charge is kind of like the same thing, but yeah, you have the right idea here.
So, doing what you did,
Mhm.
there's one pair of valence electrons on the nitrogen because there's 3.
Um,
So would it be 4, 5 minus 4 and 1 here?
um,
Or if they don't show the electrons, then there aren't there. And
yeah,
it,
this is a weird one also because they're not really showing the electrons, but which should be there, but yeah, the formal charge on the carbon is going to be 4. It has 4 electrons, valence electrons, and then 4 bonds. So, yep, you're
but
right.
the carbon, yeah, it has the 4 bonds.
Mhm.
And then oxygen only has 1 bond, so it has 3 pairs of valence electrons.
Mhm. Yeah. So formal charge on the oxygen is probably going to be
Would be +1.
because it'll lose one. Yeah.
And then so +1 -1, it cancels out and it's 0.
For the Oh, you mean for the entire structure?
Yeah.
Yeah, and then you do it for the nitrogen and stuff too, but yeah.
So A is correct.
Yep.
Okay.
Yeah. So they're asking just about the carbon atom, by the way, right?
Oh.
But yeah, still correct. Yeah.
So I think that's why, because I didn't know what like
Mm-hmm.
I just saw it was like carbon has 4 bonds, so it can't have a charge. This is where the physics started coming in. And it got really hard. So
So, okay, so yeah, let's see here. Um, okay, so
I think I literally just subtracted.
uh-huh. So if we have heat of formation, it'll be negative heat of combustion. So uh you so if you well, yeah, you will subtract something, but to know what to subtract, so like if you're using heat of formation, uh what helps me remember is what bonds are being formed in a chemical reaction, the bonds of a product, right?
Mm-hmm.
So if you're using heat of formation, you'll subtract like you'll do heat of formation of the products minus the reactants. But
Okay.
you're using heat of combustion, which is about breaking bonds. Which bonds break in a reaction? The reactant bonds, right? So if you're using heat of combustion, you'll be doing heat of combustion of the reactants minus the products. But either
This is formation, no?
was it? Yep.
Is this one formation? It says enthalpy of formation.
Yep. So no matter,
So
yeah.
it's reactants minus products, right?
So if it's heat of formation, since you're forming the
It's
products, it'll be products minus
minus reactant.
reactants. But whichever one you use will still give you the same magnitude. It'll just be a difference in charge.
Okay.
So mhm.
Isn't the product barium oxide?
Mhm.
So that's 554 minus 600 negative 634. So that does end up being C, right?
So
But I have to consider
I
like
forgot.
the oxygen.
Oh yeah, so I forgot to say that the coefficients come in as well.
Oh, so there's two of them. So it's but there's two of both. So doesn't it cancel out?
Uh oh yeah, yeah. So it won't cancel out because because these
Oh,
are like per like kilojoules per mole values.
yeah.
So the two would mean moles. But tell me, like, so to get this, walk. Tell me how you did
I
that.
literally just I think I subtracted.
Okay. So yeah, so let's do 2 times the
150
minus 2 times the uh
like
negative.
600.
So what would we do here?
Would it be the B?
Yep. Good job.
Okay. I thought about it correctly, but I just didn't incorporate the
Yeah, the coefficients, but also, you know, the sign. So like if they say formation, then
yeah.
products minus reactants. But yeah.
It's like super cool that like my brain is working in a way like, oh, I see two numbers, like I do something with them and it ends up like more or less being the correct way, but I like that you're teaching me like how to actually do it. So
Yeah, yeah.
fantastic. We went over this. I'm pretty sure I got it right.
Let's see.
Represent a change in phase.
Uh
Oh, wait, the phase change is when it's like
yeah,
B and D, right?
yeah.
Okay. I like thought about it. I remembered when we went over it, but I didn't answer.
Yep,
Okay.
yep, yep. Good job.
Um, I think this is correct.
Heat content of the yep.
I can't remember what sublimation is. I'm pretty sure it's like when it jumps from like liquid to gas. No, from like it jumps through two phases, like solid to gas or something,
Uh-huh.
which I'm gonna guess takes a lot of like heat, and I associate heat with entropy, so I thought that C would be correct.
So entropy is randomness,
Okay.
right? Like think about everything. Like you have to. No one has to like purposely make, let's say, their apartment messy. They have to purposely make it like neat, like
Okay.
and like so entropy think of as disorder. And
Mm.
so if something is what's deposition? It sounds like something that
Like a law thing, like when you give a statement.
yeah, yeah.
But I also like deposit like something
Good, yeah. You're thinking
like almost decomposing or something.
yeah, or if you think about deposit, like maybe like take something that's maybe a gas of some sort and deposit it as as a solid.
Okay.
So yeah, deposition, gas to solid, crystallization would just be liquid to solid, right?
Hmm.
Condensation would be like gas to liquid. So all of those involve a reduction in entropy because you're making a more ordered like
Hmm.
structure.
But solid to gas is less order.
Yep, and therefore more entropy, and that's
Yeah.
what sublimation is.
Okay. I feel like that's what catalysts do, right? Like they speed up a reaction by lowering an activation energy.
Yep.
I guess this one, I think.
So tell me about it.
Which of the following reaction system at equilibrium? Oh, which of the following changes causes equilibrium to shift to the right? Like, is this KM stuff?
Uh,
Like spontaneity and
it's just Le Chatelier's principle, which is like comes like behind almost a lot of things, uh, but like the idea would be like let's say that we increase this concentration.
then the other side has to decrease, right?
Uh, so the Le Chatelier would mean that the system would react in a way to mitigate.
Or equilibrium.
Yeah. So if you increase the amount of this reactant, right,
And
it's
products have.
drive it forwards to make up for it on the product side.
Mm-hmm.
And, you know, that's generally how that works. Like, you can do the same thing with if you increase the amount of this bromine or whatever.
It
It
would go to the left.
exactly. So now,
I think you showed me this once when you like drew out the arrows, right?
uh-huh. So now
Um,
one is yeah. Yeah, so this one's asking about so we could do that. Yeah, go ahead.
all of these, like, if this, where's my annotate? Okay. Just thinking this out, right?
Mhm.
Let's start with A. If I add something here, then doesn't that make this whole thing go up, which means it would go to the left?
Uh-huh.
So that means that it's wrong because we need it to go to the right.
Yep.
Lowering this would also make it go to the left.
Yep.
So B is wrong. Pressure, but this is H, so it's heat, it's not pressure.
So the thing with pressure is, so if we have gases, which we do, um, you would count the number of moles of gases on either side. So we have 2 moles of gases on the left, 3 moles of gases on the right. And so if you increase the pressure, it will go from right.
It would go to the left, right? So D, increase in temperature, would be an arrow up here.
Yeah, so how do we know like so what do we do with this over here?
Isn't this part of the like kj per mole thing?
Well, so just think about it like, so we've been talking about things like, either adding to reactants or products, right? So the delta H is going to tell you if it's,
Is it like, well,
uh,
that's why I kept thinking of, I know you're saying it's the Chateliers, but I remember like delta G,
uh
like when delta H is positive, then delta G is also positive, I think, and if delta S is positive,
so
then
that,
delta G is negative.
so, but just in terms of delta H itself, right? Um, so for a reaction like this, if it's an endothermic reaction, the delta H will be positive,
Yeah,
which would mean that you must add heat.
to the other side, right? So it would be an
Well,
arrow going this way.
uh, yeah, because if it's endothermic, which is that means the heat is added, which means it's a reactant.
Right. So then the product heat has to be brought up.
Yep. So
Okay.
that would cause it to shift right, but I just want you to see that if this was a negative, it
Then
would,
it would begin.
it, yeah. But yeah, if it was a negative, it would be exothermic, which means,
Which means the products.
yeah, heat will be at the product. Yep.
Okay.
Okay. Yep. Yep. You're right on this.
I was thinking about like heat and gases and how the molecules collide more frequently.
Mm-hmm.
This made sense to me.
Yeah, the temperature definition is the average kinetic energy of the molecules. So if there's more kinetic energy, they're going to have more energy per collision and they'll collide more frequently because they're moving faster.
Okay. This one was a complete guess because I couldn't like look at any of them and just establish where.
So now that we know about
Yeah.
the Chatelier with gases, you should, yeah.
Which of the following equilibria would not be affected by pressure changes at a constant temperature? Pressure, we said, goes here and makes a move to the left.
So pressure would affect things in the,
Products.
oh, so it just affects things in the gaseous phase.
Okay. So
It,
I have to look and identify which ones are gases.
uh-huh.
See?
So once you do that, you want to sum up the moles of gases on either side. Because
Okay.
think about it, right? We know
Uh-huh.
a mole of a gas is 22.4.
Here it's 3.
Uh-huh.
Here it's 2.
Good.
So it would move this way.
Uh-huh.
So are we looking for something that's equal on both sides, would not be affected? How many moles are on the same side? Here it's 2 and here it's 2.
Maybe, yeah.
And this is a gas, right?
Mhm.
Okay. 2 and 3, so this one doesn't work.
Mhm.
And this one's 1 and 2. So A is the only one that's equal on both sides.
Good job.
Okay. I remember this, but I also wasn't sure if this was correct.
Yep, it's correct. So, also, that would be the correct number for the amount of Torr as well. So 1 ATM would also be 760 Torr.
Okay, because I knew that Torr was something. I just couldn't remember if it was like
Yep.
if 600 was right.
Yep.
And then what is bar in PA?
So bar I don't ever think I've seen before, but it would be 1 bar.
Volume, sound.
Wait, what's up?
Would it be like volume,
No, no. So all of these,
sound wise?
so these are all going to be pressure,
Pressure. Okay.
but but it could help to remember that like 1 ATM would be equal to 1 bar.
Uh-huh.
So um
Okay, so 10 is wrong. And then PA.
yeah, so then Pascal's is like, so when you do like the formula for pressure, which is force over area,
Uh-huh.
newtons per square meter is a Pascal.
Isn't Pascal something in geometry too?
Well, yeah, a lot of these people like
Like
end up like,
Pascal triangle, I think.
yeah, yeah. So a lot of these things, like a lot of these mathematicians and stuff, also develop concepts in physics because, you know.
Because they just hated everyone and they decided geometry and physics need to be taught in schools.
So yeah, so basically oh yeah, Pascal. So that's what a Pascal is, um and 1 ATM is equal to 100 uh kilopascals.
Okay.
Um
So
yeah.
I feel like B is a trick one because if you don't remember the kilo, then
Yep. You're thinking exactly uh how you should be thinking.
okay. And then Tor was also a trick because I recognized that Tor.
Hmm.
Okay. All right.
Good
So
job.
it's good that I got it right, but I need to review this.
Mhm.
This was also a guess because I assumed that it had to be greater than 2.6 because there's an increase, and this was the only one that was greater.
Well, we want to think about like the relationship between the two, between pressure and volume.
Uh-huh.
So if you take a gas and you, or let's say, yeah, let's say you have like, I don't know, a balloon. That's not really, I can't think of a good example, but if you have like, let's just say you have a gas and in a container and you reduce the volume of that container, what do you think or okay, how about this? Like, let's say you have a water bottle.
Oh, I get what you're saying, that pressure would decrease
Uh-huh.
as volume increases.
Yeah.
So D would be wrong, but
Hmm.
so we have a 1.2 liter increase. So I'm gonna assume it's either B or C because that's a pretty like minimal change. And maybe C would be a good guess.
Excellent guess, yeah. Um,
Okay.
you know,
But there's a formula in it.
well, yeah, there's
NRT.
NRT.
Yes.
Um, and if we're just changing, pressure and temperature, like the NRT would be the same for both sides. So we could just write like P1 V1 is equal to P2 V2
Mhm.
and plug in and solve that way.
Okay, I have my.
Hmm.
Hmm.
So, but yeah, no, like you want to have multiple ways to get to the right answer, but the most important
You
way.
multiply them, 2.6 x.
Uh, so volume one is the 3. So yeah, 2
Yeah.
times the 3 divided by the 4.2.
Okay. 2.6 times 3 is like 8-ish.
Mm-hmm.
Divided by 4 is 2.
Yep. So good job. But yeah, the idea, like how you're thinking of it with pressure and volume being inversely proportional. Yep.
Mhm. Okay, can I try to redo this now that like I have the full equation?
Mm-hmm.
So EV equals nRT. Um, the temperature is changing now. So T isn't a constant. NR stay the same because those are always constants. Um, volume stays the same. Okay, so P1, T1, P2, T2,
Okay.
and then 1.5 times 320 over 450.
Okay.
Is it A?
Let's see. So you said that you did.
I just don't like really want to calculate it out.
Mm-hmm.
And isn't 15 times 3 something like, isn't it 45?
Let me see. 1.5 ATM at a temperature of 320. Um, uh, oh, so
Did I set up the equation right with the like I did it the same way that we did last time and I did
oh,
P1 T1. Or
sorry.
would it be P over T? Because
Yeah.
they're on opposite sides. Okay. P1 over T1 is equal to P2 over T2. So P1 times T2 over. Okay. So 1.5 times 450 over 320. Isn't it like 5 over 3-ish?
Okay.
B.
Yep.
Did I guess this one correctly too?
Yeah. But now,
Yeah, no, I would prefer to know. Anyway.
good job.
There was some kind of calculation that I did here. I don't know where it is in my booklet.
Uh-huh. Yeah. So for this one, you can use that fact that 1 mole of ideal gas at SCP is what volume? So so 1 mole of an ideal gas at STP is going to occupy 22.4 liters.
Uh-huh. So
So
it's just C always.
well, hold up.
Of ideal gas.
So they're saying what's the molar mass of CO2?
Molar mass is 44 grams per mole.
How much do we have?
You have more than that.
All right.
Wait, so I'm right. So it would occupy more than,
Yep.
whoa.
Mhm.
It's 3 for 3 with the guessing. Sorry. I
Yeah,
know that.
but you want to know why? That's the
I completely agree with you. I'm just shocked.
yep.
Shane, listen, I saw what happens on test day. Like guessing doesn't work. I need to know everything.
Totally. Yep.
Okay, so I need to memorize the 22.4 thing. We talked about Pico. I remember that it was -2, 12.
Good job.
This one, I remember like the first thing I learned, like when I opened a chemistry book, like when I started studying for the MCAT, was vector addition. And I'm pretty sure I did it right and it's D, but I don't remember vectors like at all, and I haven't seen it once as I've been reviewing.
Okay. So, so yeah, vector just means that it's something that has a magnitude and a direction.
Yeah, and I know you add them tip to tail,
Yep.
but
And
then subtracting I assumed would be the opposite.
yeah, yeah. So like, so you're essentially adding uh P plus negative Q. So negative Q would just be with
The flipped,
and
right?
there.
Sure.
So yep,
So then P plus Q would be A.
yep.
And then B and C would be like multiplication and division. Or
Uh, so B and C, I guess, would just be using different. Wouldn't be anything.
okay.
Yeah, you don't multiply or really divide with vectors. Like you can do, you're really just gonna do vector addition. Um,
Mhm.
so yeah, B and C won't be anything. But good job.
Is this like a uh VAT? I feel like that's the equation.
Mm-hmm.
Like VF equals VI. I don't remember.
So okay, let's see what they give us, right? So they give us a speed in some annoying unit, and they give us the time.
Oh, I remember doing this. I remember I had to convert from like kilos and hours to seconds.
Yeah, yeah.
And then it's like acceleration equals V over T, right? I have it written down.
Uh, like
A equals V over T,
when you say V,
velocity.
so
We
kind of
don't have this.
kind of close. So it'll be change in velocity.
Delta V over T.
Yep,
It was something.
yep. And so what's the so since it's a change in velocity, like what's the what the change or whatever.
From 0 to
Yep,
360.
yep. So
But it's in kilos and we need to convert 50 seconds to hours.
yep. So you already uh did that, right?
I have it written out that I need to do it. I don't think I ever did it because I wasn't sure if I was thinking correctly, but I'll do it now. Um, or maybe I did. It's just so jumbled. I like really can't tell.
So, wait. I don't see it there. Maybe underneath.
Here, I like went from this to mole, so I don't know.
Oh, you just wrote the KM to so
Yeah.
so yeah, so like what you did is right, unless it's like a guess or whatever, but yeah, you have the right idea. Um, you're gonna do the speed of
360 kilometers is,
yeah, so I guess I'll do like something like this.
isn't it 0.36 meter? No, never mind. Wrong direction. 36,000 meters, and then hours to seconds.
I think it'll be something like that.
Doesn't that cancel out hours and reduce the seconds to
Yep.
1? Or, and then you can make this, yeah. So then you end up with 3,600 times 50. 180.
Hmm.
Okay, divided by 4. 2.
Yep.
Okay. When do you need to stop today?
Let's do like let's do 2 more.
Sure. I think I literally subtracted
Okay.
40 and 10.
Okay. Uh, so tell me a bit about that.
Because
Mm-hmm.
I was thinking of like the classical like box that you draw and then like the different forces acting on it, and
Yeah.
friction is always like directly opposite, so then it ends up being like subtract it from the total, so it is 30, I think,
Yep. So you're just
unless I'm forgetting
yep.
gravity, but I don't think the gravity would
Yeah, yeah.
be
Gravity would be in the y direction, so you're just doing vector addition, but yeah, great job.
okay.
So, yeah, I think that you should give yourself more credit with the physics stuff. Uh, because yeah, I think that, you know.
Yeah, but then I'll look at this and I'll be like, oh, 10 times 2, 20. Like it
Well, yeah, you know, you want to be like, you know, like
okay.
yeah, I think you're doing great.
Okay. Um, I drew this out. I have a box.
Uh-huh. Got it. So, uh, yeah, so we can think of, you know, work as, force times the distance.
Wait, I have that work equals I have that equation written.
Yep.
Um, 10 joules of work, 10 K is equal to distance is 2. Force, how much force is applied? 10 divided by 2, it's 5.
Yep.
Cool. And here's the ramp.
Hmm.
B is wrong. I know it. I needed to put an answer down so we could go over it, but let me like actually try to do it.
Yeah, so this could be like, a new thing that I can explain to you. So like for instance, so this is under the topic of simple machines, uh
Mm-hmm.
which involve like inclined plane, pulley, um hydraulic press, and a lever. And the
Mm-hmm.
idea with simple machines like this is that energy or work will be conserved. There's no way to bypass that. But if work is force times distance, if you increase that distance value,
The work will go down.
well, if the work stays constant, right? Like the constant energy,
Mm-hmm.
if the distance goes up, then the force that we must apply must go down, right? So like
Mm-hmm.
if the box was just on the ground here and we lifted it up to the top of this ramp here without
Mm-hmm.
using the ramp, right? That work energy, so like work equals FD, and that work is going to be So 1 meter times 1,000 newtons, so 1,000 Newton meters, right?
Mm-hmm.
And so and that's because we did 1,000 newtons times 1 meter, right? To get that.
Yes.
Okay. Now, if we use the ramp, what's the distance of the ramp?
5 meters.
5 meters. And
And
then,
then the elevation is 1.
oh
Or
yeah,
that's not.
yep. So we're gonna be using the 5 meters, and then the force times the force is equal to 1,000 Newton meters.
Mm-hmm.
And we divide both sides by 5. What would you get?
200.
200. So if you lifted this box up to this point, you would have to put in 1,000 newtons of force.
Mm-hmm.
However, if you use the ramp, you only need to put in
200.
newtons of force. So that's,
So forced is the worker push the parcel.
yep,
When he is using the ramp, it's 200.
yep. And so this is could be something called a mechanical advantage, which would be like the force input, or rather, I think it's like force output over force input, or distance input over distance output. But our mechanical advantage here would be 5, meaning we we don't we the amount of work amount of force that we must do is 1/5 of that,
Mm-hmm.
or using the machine multiplies our force output by 5.
Mm-hmm.
So
Okay.
that's
All
what.
right, that makes sense.
Yep.
Okay. All right, so I'll finish this for today. I'll keep reviewing what you sent me. Should I start Psych and Soc today too?
Uh, Today, so yeah, I would still prioritize the stuff that you're the CP one, just because that's the most high yield. Like that's going to be the one that will, you know, take your score
Okay.
up more than anything. And I think
All
that,
right.
a good job. Like I understand like some trepidation in that, like if you're not understanding it, blah blah blah. But yeah, that means you're learning. You're learning a lot, like, in the past few days. So I think that yeah, I would prioritize the that
Just continuing to work my way through, like reviewing it.
yep. Yeah.
Okay.
That's like I think basically think that finishing this CP content diagnostic is gonna be like the biggest thing that will.
But I think I'm on like 113, like 100 out of 113, so it shouldn't take me so much longer today. But I also understand that like me clicking buttons and then we spend the time reviewing it afterwards, it's a little bit different.
Oh wait, what do you mean?
Like when I go through it, like there's a lot of questions that I flag and I guess on, like the one that we just did, for example. But then like you and I take the time to go through it, and then afterwards, like I understand it, and then I review those.
Uh-huh.
So I'm saying like I am working my way through it, and I'll finish like the rest of the CP questions so I'm familiar with them in time for our lesson. But like at the end of the day, I'm literally just like looking at it like if I know what I answered, if not, I just click a button and go on to the next one.
Yeah, yeah. So, I think that's yeah, that's fine. Um,
Okay.
when is your next test? Is it Sunday or it's
I
Sunday?
think you gave it to me for this week. Like I think we put it for Sunday if I remember correctly.
Yeah. So
Yes. No, it's on Saturday. It's this oh no.
I just put it on Saturday for like default, but
Uh-huh.
I think that
We're meeting on Saturday.
yeah, yes. I think that we can take that test after we finish this CP content diagnostic. So I think
Uh-huh.
that you know taking the test maybe Monday or something during the week. I know that like yeah, I know that we want to normally take it on weekends, but I think that finishing this would be the best, like most high yield thing to do right now.
Okay, so you'd rather me like push off the test a little. On Monday, I have a med school interview at 7 p.m. So
Mhm.
I think I'm supposed to be spending, we're meeting
Yep.
4 to 3 to 5, or is 4 to 5? I don't remember which
Yeah.
day.
Yeah. So
Sunday was the one that where you have 3 hour, 2 hours.
yeah. So tomorrow it'll be 3 to 4:30, and then Sunday it'll be 3 to 5. And I think we'll probably be able to be finished with this,
Okay.
with the CP one by then. And then at some point after that, you can take a full length.
Okay.
But yeah, you could also, so yeah, I would just prioritize this yeah, content diagnostic.
Sounds good. Okay.
And you're
All
doing
right.
a great job.
Thank you. All right, Shane.
All right, take care. See ya.
See you tomorrow.